Professor Rai, are you there?
Yes, sir.
Has Dr. Ghosh joined? Dr. Tamal Ghosh?
I think he has not joined, but still time is there. It is
Mhm.
59, so we'll wait 1 or
Okay.
2 minutes.
Mhm. Okay, okay.
Okay, sir. I think Dr. Tamal Ghosh has joined.
Acha, has he?
Yeah.
Yes, sir, I am.
Okay, okay. Hello, hello, Dr. Ghosh. How are you?
Yeah, I'm fine. Thank you, sir.
Okay, okay, okay. Great, great, great. Participants, I believe, are joining. Dr. Ghosh, I think we can wait for 2-3 minutes.
Yes, yes, we can. Thank you, sir.
So Professor Dan is there, sir.
Yes, I'm here. Yeah.
Sir, should we start, sir?
Uh, okay. Yeah. Please
Because
start.
39 participants already joined.
Okay. 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 Some
So
more will be joining soon, I believe.
yeah, they will be joining soon.
Hmm.
Okay, so should I start?
So before that, I will introduce uh, the your profile to our participant. So
Okay.
let me formally start the program. So good afternoon, dear participants. It is the last day of our faculty development program. So I welcome you again. So today's speaker is Dr. Kamal Ghosh. The topic is AI and machine learning in predictive maintenance. So before that, let me introduce the bio profile of Dr. Tamal Ghosh. Dr. Tamal Ghosh is an experienced researcher, associate professor, and currently affiliated with Adamas University, Kolkata, specialized in artificial intelligence, intelligent computing, and advanced manufacturing system. His work spans optimization algorithm, digital twin technologies, data-driven optical quality inspection. He has published extensively in high-impact journal and conferences and has contributed to several national and international research projects. Dr. Ghosh's recent work includes developing surrogate assistant multi-objective optimization framework and artificial intelligence powered inspection methods for modern manufacturing. He is also actively involved in academic leadership and curriculum development, bringing both research depth and practical insight to his teaching. So this is the short bio profile of Dr. Tamal Ghosh. Now, Dr. Ghosh, the session is yours. You may continue.
Okay. So yeah. So I guess I hope my presentation is visible, right?
Yes, sir, it's visible.
Yeah, okay. So today's topic, which I'm going to cover, that is the application of artificial intelligence and machine learning in the area of predictive maintenance. So since this FDP is based on industry manufacturing and industry 4.0, and predictive maintenance is basically an integral part of this area of study research. So without addressing this, this is going to be incomplete. So I guess this is going to be very insightful for whoever is attending this FDP, all the researchers or faculty members or uh, students. So I think it will be helpful for all of you. So before I start my topic, uh, this topic is based on, as I said, artificial intelligence or machine learning in the area of predictive maintenance. Now, if we focus on predictive maintenance, we will see that there are two terms involved. One is the prediction, one is the maintenance. So, first of all, maintenance is a manufacturing area of research and study. Maintenance is basically the strategies which play a very decisive role in determining productivity, safety, and cost efficiency in modern manufacturing systems. Uh, it is very old method or old technology we are using from past 100 years maybe. So the traditional approaches in maintenance, such as breaking down, so the traditional maintenance approaches which could be breakdown, which we can break down into uh, there is some noise coming in anyways. So the traditional maintenance approaches which could we can break down into maintenance and time based preventive maintenance, which are quite adequate in industry 4.0 environment, where systems wh- where systems are highly automated, interconnected, and data rich. Now, when we add predictive or prediction with maintenance, then it becomes predictive maintenance. It represents a paradigm shift. So it leverages data from machines, sensors, production systems to predict failures before they occur. So basically, the importance of predictive maintenance is to reduce the downtime and align with the goal of today's smart factories. Productivity should be increased, your resource utilization should be optimal, then labor utilization should be like all all the resources should be properly utilized in the systems. So basically, maintenance is all about addressing the failures in the system. Now, manufacturing systems, when we deal with the manufacturing systems, the traditional manufacturing systems consists of various uh, very expensive machineries which are bound to fail. So, predicting those failures before they occur could be very helpful when we in today's smart factory environment. So basically, this kind of predictive maintenance, they allow maintenance action to be planned proactively. And since this is predictive maintenance, then we need to find out why AI ML is included in this. Now, artificial intelligence and machine learning are the core enablers that make this prediction accurate, scalable, and adaptive. So, this is the basic or introduct or we can say the definition of predictive maintenance, how AIML are clubbed with this predictive maintenance thing. Now, in this session, basically, we cover the concept, models, and implementations, at least some introductions for all the attendees, and some level of technical depth, like discussion on the algorithms, models, and deployment, and some learning approaches, like some case examples, research directions, and all. Now, first, the since we are already talking about predictive maintenance and its concepts, and the maintenance life cycle is part of this. So, first of all, we have to understand the evolution of maintenance strategies. So, we said that breakdown maintenance is one of the strategy. So breakdown maintenance means maintenance performed only after failure. So once your machine or system is failed, then maintenance is performed. Or then say if there could be high downtime if we follow this strategy, and there could be a safety risk also, and it is suitable only for non-critical equipment, because if the equipment or machinery is very critical to the process, then quick maintenance is very important. Otherwise there could be a loss of uh, money or time and many other things. So this is the primitive process, which is breakdown maintenance. Next one is preventive maintenance. This is another strategy. Preventive maintenance is quite useful. It used to be quite useful before the modern industry 4.0 era. So preventive maintenance says we have to schedule at fixed times or usage intervals this maintenance thing. So it is more like a periodic maintenance. So if we allow periodic maintenance, that can actually reduce the catastrophic failures in the system. So that is also one solution which is better than at least breakdown maintenance, and it often leads to over maintenance and sometimes unnecessary cost. So if we perform preventive maintenance, there is nothing harm in it, except that sometimes if your machineries or systems are not it if it is it if the machinery does not require any kind of maintenance, then also you are doing it because it's a routine maintenance, so it is unnecessary cost and manpower involved. So this can be one drawback of preventive maintenance. Next strategy is condition based maintenance. So condition based maintenance is more like decision based on real time condition monitoring. So it is not exactly preventive maintenance, but it is something which lies between the preventive maintenance and predictive maintenance. So we use some sensors to analyze the collect the data and analyze the data to see the condition of the system, and then we do the uh, maintenance. So using sensors, using we can predefine some threshold values. How the threshold values are collected from the experts who are working in shop floor. So there are some limited predictive capability also of this system. So after condition based maintenance, there comes predictive maintenance. So predictive maintenance uses historical or real time data. So it is also you can say that condition based maintenance is part of predictive maintenance, because we also use sensors in case of predictive maintenance. We also collect data, data of the machine states, data of the environmental like the say temperature or any noise or any movement. We can collect all this kind of data using sensors, and also we can analyze the historical data if some data are available, and also we can merge the historical data and real-time data together, and we can use artificial intelligence and machine learning algorithms. So we can identify some suitable AI and machine learning models, and we can apply, and we can find some trade-offs, or we can optimize the task of predictive maintenance. So we can optimize the maintenance cost, downtime, asset life. So it is a process which where we can use this predictive maintenance to analyze all the system data, and we can find out the proper schedule when which machine is going to fail, or which is whose life time is going to be over. We can use this data and all, and we can predict their maintenance schedule. So predictive maintenance in industry 4.0, uh, well, first of all, when we talk about industry 4.0, we also encounter as another very interesting terminology, which is called cyber physical systems, or CPS. And CPS is an integral part of industry 4.0. CPS is nothing but a physical a cyber existence of a physical system or machine. And also there we need industrial IoT, or internet of thing, and then cloud computing and AI driven analytics, data analytics we should consider when we use predictive maintenance. So predictive maintenance fits naturally into the this ecosystem, because it also needs all this data and all these applications. So to enable predictive maintenance in the industry 4.0 scenario, we need to use this, as already I said, smart sensors, and sometimes we need another a device called edge device. Edge device is like a computing device which can be which we can install at the system end or machine end, we can say. So the reason why we do that, because sometimes a central computing system is not a very suitable choice when we have a very complex kind of setup in the factory, and all the machines data are being analyzed in one single server or machine, is something which is not very optimal decision or task we should do. So it's better to distribute the task to the machine itself and attach some uh, edge device on the machine end, and which can, so for each machine if we can assign some edge device that is capable of doing the computation like executing the AI models, then every end in near to the machine, we can, in the vicinity of the particular machine or system, we can analyze the data. So edge devices are very useful. And but if we need to have some synchronization between the data transfer, we also need to have very high speed connectivity and cloud storage systems where we can store our data properly. So cloud and edge computing platforms are very vital when we think about predictive maintenance. And then we need advanced data analytics and AI models to analyze our the collected data. Predictive maintenance basically transforms the maintenance from a reactive function into a data-driven decision-making process. So predictive maintenance is all about the data-driven approach. So in the industrial scenario, mostly if there is a central factory setup for any company or any um, manufacturing organization, and they have multiple other sub factories which are distributed throughout the country or throughout the globe, then this kind of applications are very useful, because it is not possible to visit for the technicians, it is not possible to visit all the factories and then do this task at one go. So if things are connected through internet, then it is much easier to access the data and find out the. So it is like solving this challenge. It is possible to solve this challenge using predictive maintenance. So predictive maintenance uh, concept is very useful and very interesting, and also it is being researched heavily at the moment, because there are lots of issues when, since we are talking about data, we are talking about internet, we are talking about data transfer. So privacy is one very important aspect. So there are lots of issues related to data. When you transfer it, how you transfer it, what is the process of coding, decoding the data. What if data is very costly, expensive? So it so privacy is very important. And then other issues like how to integrate some systems which are uh, different to each other. So there should be some proper integration method being used, and also operational hurdles, if there is any, that should be addressed. So these are very important things which should be, or you can say challenges which should be taken care of. And then uh, when we analyze the data using machine learning and artificial intelligence, quality of data is very important aspect. We should we should actually maintain. So these things are something we should be very careful about. But this predictive maintenance, since it's a concept, and it is not actually a concept at the moment, it is being applied by many throughout the globe. Many companies are applying it. So mm, it is now a part of research, and it is being taught in many advanced institutes, and even in our country. And also this kind of technology are being through lab, it is being like industry 4.0 labs are being developed in the institutes, so that these technologies, students can learn these technologies. So proper so translating this research into curriculum and lab experiments also some goal for the faculties. So it is like mapping with the experimental design with the curriculum and all. So predictive maintenance is becoming an integral part of the advanced manufacturing education at the moment. So this uh, maintenance evolution we have already discussed. Now the thing is, why predictive maintenance is very important. From this we understood that, first of all, uh, it can reduce some unplanned downtime. So it can anticipate failures to keep lines running and avoid production losses. It can extend the equipment life. So proper maintenance can actually help the equipments from falling into the failure trap, and it can reduce the wear and tears, and it can postpone the replacement. So it is a cost effective method, and also improve product quality and workplace safety. So if fault detection if early fault detection can be performed, then defect can be prevented, and it can reduce the safety incidents. And the KPI to monitor qualitatively. So like uptime, then mean time between failures. So these all metrics and maintenance lead time can be used to monitor the system. Okay. So, when we talk about predictive maintenance, we have a system architecture. And a typical predictive maintenance architecture consists of various different layers. First of all, the physical layer. The physical layer, in the physical layer, we have machines, tools, equipments, and then we have sensing layers or sensors. So, sensing layers, we have various sensors. What kind of sensors we can think of? Like vibration sensor, temperature sensor, acoustic sensor, power sensor, image sensor. So, various sensors we can use. Another sensor we can use, that is force sensor. So these sensors are also different types of sensors we can use. There could be there could be very high precision industry grade sensors you can use. Sometimes in industry they use those piezoelectric sensors which are very precise, and also depending upon your requirement, some low cost microcontroller based sensors could also be used. So it all depends on what kind of process we are dealing with, and what kind of, how expensive uh, the equipment we are trying to maintain, perform the maintenance. So after that, there is edge layer. We already said edge computing. We already talked about edge computing. So edge layer means uh, from sensor, when the data is transferred to the computing system, that is the edge, that is performed through edge layer. So signal conditioning, filtering, real time analytics, these things we perform in the edge layer. So data we collect, which is raw data, there could be lots of problems in the data. So pre-processing is very important. So we can perform the low latency interfacing and local filtering to reduce cloud load. So, and also in machine learning or in artificial intelligence, there is a terminology which we use. It is called feature engineering. So if we can apply feature engineering and we can reduce the number of features from the data, then also the cloud load can be reduced. Next layer is the cloud or data layer. In the cloud or data layer, the data storage is the main task, and also large scale processing. So say a centralized model training, fleet analytics, long term storage, and heavy computing can be performed on cloud storage. So nowadays, many different organizations, many different companies, they're offering the cloud storage like Amazon, AWS, then many other companies which are coming up with the this cloud storage, which can be used industry from the industrial perspective. So after cloud layer, we have another layer which is called AI layer, or where exactly we perform the AI model, we create the AI models. So anomaly detection and prognostics modeling that can predict faults and remaining useful life. So fault detection, diagnosis, prognosis, prediction, all can be done in this layer. AI models, they predict, they can classify the data, they can predict the output, and they can make the system learn adaptively. So there are lots of different approaches this AI models can help with. And finally, we have a layer called decision layer. So AI is nothing but some approach which can help us to make decision. It is more like using an artificial brain. So instead of using human intelligence, we are using the artificial intelligence. And the purpose of using artificial intelligence is the same the purpose of using human intelligence, like reaching to a conclusion or making some decisions. So decision layer is where we perform the decision task. So it in this layer we translate the AI model's result, like the prediction result or classification result, into the actions. So maintenance schedule, like we can generate the maintenance schedule, we can generate the alerts, and we can set up the controller set points and all. So you can also generate the work orders. So every decision which is involved in the production process, those can be implemented in the decision layer. And finally, this is an optional layer, which is a feedback loop. Feedback can be there or may or may not be there, depending upon the kind of process we are trying to apply the predictive maintenance. So in the feedback loop, what we do, the real-time route for model outputs back to the controllers and maintenance planners for actions. Or also sometimes if there is any, we try to check whether the AI model's result is quite close to the real life result. So if we have historical data, we can send the result through the feedback loop to the system and to analyze whether the AI model is perfect or not. And we can make it perfect after many number of trials and all. So this is basically the architecture of predictive maintenance. Now we can talk about the data sources. So since it is predictive maintenance and we are talking about AI modeling and machine learning and all. So machine learning is a kind of artificial intelligence technique where we can use where we actually need to use data, because machine learning is machine learning is a class of algorithms which can be applied on data only to find out the patterns from the data. So since it is data driven method, so data is very important. And when we are talking about data sources, we need to identify. So first of all, the mechanical data sources, like say vibration data, acoustic emission data. So you can detect why we need this, because vibration can damage the tool life. So it can detect the bearing wear and rotor imbalance also. Acoustic emissions can it's like crack propagation and friction events. So and also the temperature profiles. Temperature profile could be so it is these are all the sensor based data. So mechanical and thermal data. And so thermal imaging is like hotspot detection and insulation fault. And there could be image or visual data, which is data source which is like visual inspection for surface defects and leaks. So you can use various image sensors or camera modules so that we can check we can capture the images, still pictures, still images, or videos of the product surface, and then we can check or verify if there is any defect present there or not, and we can train the model based on that. And also there are electrical and environmental data source, like say power consumption, So you can analyze the power consumption also, like motor overload and inefficiency you can analyze, and temperature is also we can check. So basically there are the data sources. There are sensor based data we already have seen, and there are operational data, like we can collect the operational data like machine logs. Sometimes machines itself they generate lots of data, like say PLC data, SCADA data, MES, like from the manufacturing execution systems. We sometimes find out lots of data. So these are all the data. These data are collected physically from the machines itself or the system itself, and also conditional data, uh, duty cycles, etc. And the third kind of data, so sensor based data, operational data, and the third kind of data is the visual and imaging data. So this kind of data we can actually collect from we can use for predictive maintenance task. Now when since we're talking about data sources, next is the data preprocessing. So data preprocessing is very important. I said when we send the data to the edge layer, data preprocessing is something we need to think about, or we need to apply. So raw industrial data is basically very noisy and heterogeneous, or we can call it unstructured data. So unstructured data are not useful for the machine learning or artificial intelligence methods. So in those cases, we need to apply effect. We need to use some methods in order to make them useful or usable. So that's why we need to perform pre-processing, and pre-processing can be like noise filtering or missing data handling or normalizing or scaling of the data. So noise filtering is all about removing all the unnecessary um, data points which are actually work as a noise, not actually useful data. So we should filter them. And then missing data handling. So sometimes when we collect data using machines, there could be lots of missing data or garbage values in the data. So handling those data is very important. So either you have to discard them. That is the easiest way to handle it. But discarding some portion of the real life data can make the system unstable, because based on that, if we do some analysis, then that analysis could be erroneous, because um, ultimately we are trying to find out the pattern from the data. So if a part of the pattern is missing, so it could be problematic. So it's uh, better to predict the missing data points if there is any. So missing data points can be predicted, and then after that those can be incorporated in the original data and can then we can then process it further. And normalization and scaling, why we need it? Because data features are not always in the same scale. Sometimes they are different from each other, and they're different in scale. So with respect to some data feature, other features can become trivial when machine learning or artificial intelligence models handle those. So to avoid that situation, what we do, we apply some normalization or standardization method to scale them from 0 to 1, or say -1 to 1, in this range. So it is very important. Then feature engineering, I already mentioned once, feature engineering, which is very important. Feature engineering is all about selecting the proper features. So you have to find out using there are lots of algorithms and methods available in machine learning and artificial intelligence, which can be used to understand which features are more contributing towards the system and which are not that contributing toward the output. So basically we can use those algorithms to find out which features we need to select out of all the features. So there are many algorithms. I can give one or two examples like principal component analysis or multi-dimension reduction methods. So those this kind of methods like PCA uh, or ICA, they can actually um, lower down the number of dimensions, means number of features. So basically, it is all about selecting the most important features from the data. That is one way. Another way is that uh, combining the combining multiple features into one feature. So that is also another important task. If some features are contributing but not contributing that much, in those cases we can combine all those features which are like contributing a bit to the system's output. So feature engineering is very important. In feature engineering, basically we in feature engineering basically we can have time domain features, frequency domain features, and image based features. So time domain features are like mean, RMS values, variances. So all the statistical values from the data we can extract, and then we can detect the non-Gaussian transients. So it's like skewness and kurtosis. So these all are statistical measures we can use for time domain features. Then frequency based features, we can perform the spectral peak method like fault harmonics and sidebands, and then we can perform the spectral entropy based methods, and then image based methods we can perform the textual features like GLCM. This is a old method, a matrix based method, but very useful, which can actually extract all the features from the images. And also there are modern methods like neural network, like convolution neural network embedding. So it's learned representations from the thermography. And then so these are the different kind of feature engineering method we can apply. And next is the machine learning or AI modeling, which we are talking about. So basically, when we talk about machine learning, there we have to understand what kind of machine learning methods we need to apply. Now, in case of machine learning, it depends on the kind of data we are using. So the data, if it is a labeled data or the data is not labeled. So that means suppose we have a process a historical data available with us, where the input and output uh, data values are available. So if we have suppose the parameters values, which are say input values, and the response values, which are the output values, if we have all those values available or all the data available from past, then we can have a guidelines like which kind of inputs gives which kind of output, which we can find that. So in those cases we can apply some so if we use those kind of level data, then we can actually create machine learning models which are supervised in nature. But if the response or output values are not available, then that means we cannot use supervised learning method there directly. we have to use the unsupervised learning method. Now, the supervised learning method is used when the fault data is leveled, and those methods examples would be support vector machine, random forest, XGBoost. So these methods are mainly classification based methods. They We can use them to classify the data, and also we can use regression, linear regression, non-linear regression, uh, multiple linear regression, so then logistic regressions. So this kind of regression methods can be used if the data is leveled. So basically the applications for supervised learning models could be fault classification, health state prediction, etc. Means machine health, of course. And for unsupervised learning models, we used when fault levels are almost zero, like like unavailable. So in those cases, we have no guidelines. Like say, if we are classifying the data, then we have no guideline, like no previous data. So in those cases, we can use these unsupervised learning methods. Those methods are like k-means clustering algorithm, then isolation forest, then the modern methods like autoencoders. So for anomaly detection or novelty detection, we can actually apply these algorithms. And now we can talk about deep learning models. Now, first of all, what is the difference between machine learning and deep learning? Well, in very simple term, machine learning methods are those which can handle less complex data. When you have in your data, you have less number of layers, or complexity layers are less, then we use machine learning. But sometimes machine learning, if suppose your data has multiple layer or complexity, or complexity layers are high, or say you have thousands and thousands of features, or conflicting in nature, they are dependent on each other, data is non-linear. So in those cases, simple machine learning methods are not very useful. And in those cases, we need to use the deep learning models. So deep learning models are basically the neural network models, which are more like work with layers. Uh, if anybody of you have studied deep learning before, neural network before, you will know that in deep learning we have various neural network models, where we have along with the input layer and output layer, we have multiple hidden layers. More complex data, more number of hidden layers, so that the model can learn very complex patterns from the data. So so basically, when your data is very large scale and it is high dimensional, deep learning models are very useful. What are the different kind of models you can use? Like convolution neural network. This can be applied for vibration analysis. Like we can collect the vibration signals or images, and we can analyze those. Then automatic feature extraction can also be done. And next is recurrent neural network, or RNN, can be very useful. In case of RNN, one very popular and interesting method is LSTM, or long and short term memory, that can be used on time series data, and widely used for remaining useful life or RUL prediction. So there are various different kind of methods. Another one is, which is very modern method, which is called autoencoder, and it learns the normal operating behavior, and deviations indicate faults. So uh, autoencoders are very useful for anomaly detection as well. And also we can create hybrid pipelines, like say CNN LSTM hybrid model, or CNN with autoencoder. So this kind of hybrid model, or we call it ensemble. So ensemble models are very interesting and useful models, which we can use for uh, to build this model for fault analysis and all. So okay, so next, since we have already understood supervised and unsupervised methods, now you can see there's a table I have added here, which actually can compare these two different kind of approaches based on data requirement, level dependency, industrial suitability, and typical outputs. So for data requirement, supervised learning or supervised predictive maintenance requires level failure data. For unsupervised, of course, it requires unleveled normal operation data. Supervised method depends on explicit failure levels for training and target prediction, and unsupervised relies on models of normality, anomaly scoring, and no failure levels required. Industrial suitability is based for well labeled equipment fleets with recurring failure modes for supervised methods, and for unsupervised methods based for rare failure context or new assets with few levels. And the typical outputs: failure class prediction, remaining useful life estimates when levels exist. And for unsupervised method, anomaly scores, early warning alerts, and unsupervised fault clustering. So different methods can be used and or serve different purposes, and those can be very useful for their purposes. Remaining useful life prediction is a is an approach which can estimate the time before a component or system fails. So RUL prediction enables maintenance scheduling, spare parts planning, risk-based decision making. Common approaches like, say, regression-based ML models. Since prediction, we are actually predicting the schedule, maintenance schedule. Anything we want to predict, we need to apply the regression-based model. Now, we are talking about prediction and classification. The thing is, what is the difference between prediction and classification actually? So, prediction is all about like the output, whatever result we get, that data is continuous. And in case of classification, whatever output we get, that is not continuous, that is discrete. So classification is all about groups or classes. So for an example, uh, if you are analyzing the machine states and you want to classify as machine is useful or not, so it is like 0 and 1 binary classification. Or but in case of prediction, if you want to predict the schedules, that is not say that is not some discrete data, that is a continuous data. So that can be that is why we need regression to do that task. So regression based ML models, and sometimes we can also apply LSTM or recurrent neural network based sequence prediction. It can be applied on time series data. and hybrid physics informed AI models, which are much more complex models, which can be trained on the data. Next is optimize maintenance with predictive models and digital twins. So we can integrate the optimization and digital twin with the predictive maintenance. How? Well, first of all, what is optimization? Optimization is all about using some algorithms which can give you some trade-offs. So it is like, say, cost versus downtime trade-off. This is an example. So predictive maintenance become more powerful when we combine it with this kind of optimization algorithms, and we can find out the trade-offs. And sometimes digital twins. Why digital twins? First of all, what is digital twin? Digital twin, a replica of physical system in the virtual space, which we can connect with the physical devices, and where could be a seamless two-way data transfer from one twin to another twin. So a digital twin have any kind of digital twin has some physical counterpart or physical twin. So we can create a digital twin of a machine. So the physical machine becomes a physical twin, and the digital version of it, the say CAD model, becomes the digital twin, and we can use proper algorithms and other technology. You can use various different technologies you can implement here, so that you can connect between, we can create a good connections between digital CAD model with the physical system, and making changes in the physical system can also reflect in the digital version. And if we change something digitally, then that can be reflected in the physical version too. So this is all about the concept of digital twin. Now, why digital twin is important here? Because digital twins are for simulation and what if analysis. So digital twin can be used for scenario analysis. We can create a fictitious scenario, and then we can actually uh, test what will happen. So what if analysis we can do. So AI driven predictive maintenance within a digital twin allows continuous performance monitoring and system level optimization. Very simple. So we can see that policy testing loop. So we can test any newly developed policies. We can if there is any maintenance policies we have, we can test that them. So all these features can be we can have access with digital twin. So there could be some cases, say CNC spindle failure case study, earlier detection of wear. So if you have worked with CNC machines, you have seen that the spindle where the tools are connected, those has a chance to get some wears. Too much use of uh, tools in CNC machines, there could be wears or cracks on the tools, or sometimes more vibration can create the cracks also. So the problem is unplanned spindle failures causing production stoppage. So that means we should have a proper maintenance schedule or proper prior knowledge uh, about the tools and all. So frequent interruption can happen due to sudden spindle breakdown, which is not wanted in this in our case. And next, so this is the problem that should be addressed. So we need, so then we can understand that in this case it is only possible that if we implement predictive maintenance, then this solution, we can have a solution to have greater tool life, or less spindle breakdown. And to do that, we need to have data, and the data can only be collected using sensors. So vibration signals, spindle power signals can be collected using sensors, and sensor streams preserved as thematic data for modeling. Next is we can create the models, anomaly detection plus supervised classifier and regression for remaining useful life. And so we can create the pipeline, AI pipeline, and that can detect the anomalies, then estimates the remaining useful life. The result is earlier detection of spindle wear and fewer unplanned stoppage, which is very useful, and qualitative improvement in lead time to intervention. So the lessons: data collection, leveling effort, and deployment challenges. So leveling was time intensive and deployment require edge integration. So, but everything is possible because this kind of work uh, is possible to be done in the laboratory environment nowadays. If we can use proper edge computing device, which we can, if we can attach that with the with the CNC machine, and we can place the sensors properly in and around the CNC machine, then data collection becomes very easy. And if the model we are training, if we can train it in the cloud, then we are not using the high computing resources, or too much computing resources we are using locally. So we can use cloud computing environments such as AWS and all, and we can then create our model, and we can find out the pattern, and we can get the prediction or maintenance schedule and all, and then we can apply those back to the system to reduce the downtime of this system. So this is one case study, and next one is the the gearbox and motor fault detection. So here also the problem is that so basically the problem is that this gearbox and motor can have failure. It can be failed in sometimes, and unplanned failures should be addressed. So we need to have proper sensors implemented, so we can collect the vibration, acoustic emission, and power consumption signals with attention to mounting and signal quality, and then you can pre-process the data, can denoise them, synchronize and normalize the signals, and address signals to noise ratio and mounting the variability. And then we can extract the features, we can compute time and frequency domain features, and envelope we can perform the envelope analysis, and then we can create the models, train and validate the models, and evaluate transferability across machines and domain adaptation needs. And then we can perform the edge deployment the same way we have done it, we can do in case of CNC fault detection. And then we can deploy the lightweight interface at edge for real-time early fault detection and low latency alerts. And results and benefits would be earlier detection of bearing and gear faults and ability to plan maintenance window. So deployment notes, you can consider sensor monitoring, signal to noise to the rest ratio, and model transferability, and routine recalibration of the systems or wherever it is required. So this kind of problems you can solve using predictive maintenance. And another industry where, which I like to mention, which is not there in my slide, uh, another industry where actually predictive maintenance is very important, and that is the this where that is these electricity generation companies, where basically they use very expensive machineries like the windmills and turbines and all. In those type of systems or setups also, predictive maintenance is very important, because we can use proper sensors in and around the systems, so that we can perform condition monitoring and of the system, and we can collect the data, and then we can analyze, and we can create proper maintenance schedule. Because those kind of heavyweight, very expensive machineries or equipments, they need proper maintenance schedules. So the companies who perform the reactive, who perform this preventive maintenance, they charge huge amount of money to the organizations. So predictive maintenance is very crucial for those kind of industries also. Now, there could be some implementation challenges and mitigations. So, like say data scarcity for failure cases, data if data like if we actually want to build the proper AI model, proper availability of data is very important. If data is less, then this AI model or prediction result would not be very accurate. So if data is scarce, then it is not be possible to handle the this problem actually. So that is one issue we need to address. So data should be available beforehand, or if it is not, then we can use proper engineering methods to augment the data, and or we can create we can use the simulation tools to generate more data. So without data, it is very difficult to train our models. Then next is model generalization across equipment variations. So for validation and domain adaptation, model generalization um, could be one challenge. So basically, it is better to create models for different equipment variants. That is the reason why edge computing is very important. If we are using one single system or server based computing approach, or central computing approach, if we are applying that, then model generalization could be very much problematic. uh, Age deployment constraints. Age deployment constraint is another problem. We still don't have very high power or very high capable, high end computing systems which can be used as edge devices. Uh, it will take time to develop those very high processing units which can be used as edge devices. So, or another solution could be developing lightweight AI models which can be useful um, for edge current edge devices. But the thing is, deep learning models are very heavy models, and those so more complex data means more complex model or heavyweight model, and heavyweight model are difficult to run on the edge current edge devices. Another problem is organizational resistance to change and process integration. So basically, it is more like change management in the current organization. People sometimes are happy with what they have in their system. They don't want to incorporate this kind of advanced technology, because everywhere we hear this buzzword that AI will eat up the jobs. But so that could be a very crucial issue when a company is planning to implement this kind of approaches, and their people or the employees, they will try to resist to deploy this kind of systems inside the organization. S- So these challenges are quite important, which should be addressed. Now, this is mostly the theoretical aspect of the and also applications of the predictive maintenance. Now, what are the research opportunities in this we need to explore? So, one aspect is from the computing angle, like hybrid modeling. So, physics based plus data driven fusions both can be incorporated in one model, and it can create more real time model for analysis purpose. Then you can apply the transfer learning for cross machine adaptation. So study domain shift and fine tune the strategies, experiments transferring models across plants, and then federated learning for privacy preserving models, design aggregation and heterogeneity robust protocols, test on distributed sensor network, sustainable manufacturing, energy efficient sensing and computing. So this is another goal which actually very important, like sustainability. So quantifying the energy accuracy trade-offs, prototype the low power sensors, designing or creating low power sensors and edge interfaces could be research area. So these are the focus theme for PhD projects, then grant applications, curriculum development. So yeah, and the if we want to explore the predictive maintenance teaching area, like theory and practices, so hands-on lab, course modules, industry aligned mini projects, like course modules say foundation of predictive maintenance, features, failure modes, sensor modality, then modeling and evaluation, like remaining useful life, anomaly detection, benchmarking. This could be useful for teaching, and deployment and ops operations, like edge inference, data pipelining, ML operations practices. So this could be course modules, could be introduced in the to the students. And lab ideas could be like vibration data collection from small motor using accelerometers. Nowadays accelerometer sensors are very inexpensive, you can say, or cost effective, which can be used in the laboratory, and data can be collected using some Arduino microcontroller boards and directly in the computer or PC. And then thermal imaging exercises for hotspot detection and pre-processing, and end-to-end predictive maintenance pipeline, like ingest, feature extraction, model training, simple dashboarding can be used. Dashboards are very useful web applications or apps which can be used to continuously monitoring the system's existing or present conditions. And using graph charts and plots, you can actually find out if there is any anomaly being introduced in the system, or if there is any pattern problem in the pattern in the data feed or something like that. So these ideas are very useful for labs. And mini projects ideas could be data set creation and benchmarking. So curating the new data from the laboratory or machines and benchmarking them with the documented baselines would be very good. And age deployment, proof of concept, model pruning and latency validation, and digital twin experiment. linked to an optimization task, and RUL or remaining useful life evaluation could be very useful for teaching mini projects to the students. So predictive maintenance, data-driven maintenance for Industry 4.0. Um, Predictive maintenance is core to Industry 4.0 at the moment, like data-driven maintenance, and positions as foundational to modernization strategies or modern smart manufacturing environment. AI/ML deliver actionable predictions and prognostics for, and say, anomaly detection to remaining useful life forecasting. All this research and teaching opportunities span modes like deployment, human factors, learning algorithms, and next step could be pilot the data collection and prototyping the models to validate the data, model feasibility testing, and creating the teaching materials and all. So mostly these are the topics which we have discussed, which falls under this topic from the predictive maintenance and application of artificial intelligence and machine learning. And at the beginning, I have introduced some learning outcomes. So from the learning outcomes, there could be MCQs. These are some samples. So mm, I have a mapping of MCQs from like in which learning outcomes, which MCQ is connected. So these are just samples. So this kind of questions, example questions, I can show that how this session learning outcomes can be mapped with the MCQs. And finally, some modern references which are very useful if someone wants to go for further reading. So these are some good books and journal papers which you can go through. Okay. So this is all about from my side, and thank you for this session. And thank you to Seacom Skill University for giving this opportunity to give this presentation or take this session. And also thanks to EICT ATAL program. Thank you.
Dr. Ghosh,
Yes, sir.
let me tell you that it has been a thoroughly absorbing presentation. In fact, I was really thinking that, am I audible?
So,
Yeah. I was thinking that there are many faculty members who are relatively younger and young, and uh, perhaps many of them, or several of them at least, are preparing to go for their PhD. And so the research orientation in this presentation was really remarkable. I mean, you have discussed the tools in such a fantastic way that one would immediately get a clue as to what kind of tools are available for a category or group of problems. Thank you so much for going into the details of those tools, techniques, methodologies. Very rarely we get to see that. Rarely we find that one is going to that depth. But in your case, I would say it is a very, very, again, I repeat, an absorbing presentation. Um, and also, you talked about the project writing, which is for the young faculty members are very, very important. Even those who have completed their PhD,
mm,
who are planning to write their projects, I am very sure and confident that it will help them that how to develop the work so that it can be come up to the shape of a project. So these are my some comments which I thought I must share. Otherwise, I will not. I'm not doing my duty.
Mm.
This was our duty bound to tell you.
Yes.
Okay. I mean, if
Okay,
there
sir.
must be other
Thank you, sir.
questions from participants.
Sir, it was a very nice presentation. Sir, what I have a question that I am working in denoising application, like which you said that every method has a different application. So can I use sir GAN for image denoising purposes?
GAN you are talking about.
Yes, sir.
Yes, you can, but the thing is, it depends on what kind of data you are using, and means as I said, the different method, different approaches, they demand different kind of algorithm. Now, like you have to. It's better not to. From my point of view, it's better not to stick to some one or single method. Always try to apply more than one method, and then compare them and choose the best one. So if even if GAN is giving you a very good result, you never know that there is another new method is there available or not. So my suggestion would be, if you go with GAN, then use some other competitive method also, because you don't know what is the nature of your data, or what kind of hidden pattern it can have, it can actually show. So that is something I would suggest.
Thank you, sir, for your suggestion. Thank you.
Mm.
Uh,
Any
uh,
more?
Professor Kundu, is there anything in the chat box?
Hello, sir. I think Professor Kund is unavailable, but there is no question in the chat box.
Okay, okay. I believe the methods that were discussed is quite sophisticated, and um, for it needs some kind of study first before one can actually arrive at a situation where they are able to ask questions.
Yes.
But for sure, I'm sure that there will be some faculty members here who would go through this presentation and would explore what these methods and tools and techniques are, and try to apply in some of the problems, or at least a major problem they are trying to undertake. And then possibly some questions actually will come, because it often happens if you are listening something for the first time, in I mean first time in the sense that in that depth, in that order, then possibly the question will be asked later.
Yeah.
So if you feel that some people can write it in the chat box, you may.
Sir, I want to point out one thing, that if some faculty members are interested in pursuing their research in this direction, then actually one single session, this kind of session is not enough. Mm, this is just an introduction to predictive maintenance. Now, there is a entire unexplored area of artificial intelligence is there. So if someone is interested, I would suggest to do some nowadays lots of online courses available from good universities and institutes. and they are offering some machine learning and artificial intelligence courses, or also there are NPTEL courses being offered by various IITs. So those courses they can take up and they can go through in much they can get much deep insight from the subjects and courses, and then knowledge, and then they can go ahead and apply that in their research, I would
Yes,
say.
of course. I mean, that is
Mm.
why this course is kind of assimilation of various technologies you can understand. Now,
Yeah.
if one wants to go into the depth of predictive maintenance per se, then
Mm.
obviously what this course is expected to, it is expected to inspire and put the and get help them to gather the information. And
Mm.
if one wants to explore in detail, obviously one talk or one session is only the can only be the starting point, and from there one will start his journey or her journey, so that there will be many such sessions like in any research work that is being undertaken. Say first session with your supervisor, but that is not the end of the discussion. So
Mm.
first session, second session, third session, and then it picks up the velocity and then acceleration and it goes on. I'm sure some faculty members will definitely do that and will benefit themselves.
Yeah.
Professor Roy, I mean, I think now whatever you
Yes,
said.
sir. Yes, sir. So if there is no question is there, then we can conclude and end the session. So thank you. Thank you, Dr. Tamal Ghosh, for your nice and lovely presentation. So thank you. I am requesting all the participants to join the next session in the link provided. Thank you.
Thank you.
Kindly, dear participants, please fill up feedback form. I share in chat box. It is mandatory. Please.
Professor Sarkar, are you talking about the feedback form?
Yeah,
Yes, sir.
yeah.
Okay, okay,
It is already given, sir.
okay, okay.
All of you are requested to fill up the Google form and join the next session.